Okay, well, we are at noon. I can see the number of participants growing rapidly. And I am just going to get started while people are still joining, because this is just the relatively boring introductory part. And by the time we get to the heart of the matter, I think we'll have everybody in. So I'll just start by saying hello and thank you to everyone who is joining. Thank you for joining us and spending a little bit of time with us to talk about biometrics at the edge. I'm Chris Burt. I'm managing editor of Biometric Update, which you may know as the world's leading source of news, information, and insight about biometrics and digital identity. If you are going to be in London for Digital Trust World, please come and join me. I'll be hosting a panel there. That's this coming Monday in London. If you want any more information about me than that, you can look it up. It's really not that interesting. I actually want to leave most of our time today for our panelists, because we've got an excellent panel today of experts here to offer insights from various perspectives on today's topic, which again is biometrics at the edge. Now we're going to get into what exactly that means very shortly, and then we'll get deeper into it as we go. So we're joined today by Innovatrics Business Development and Product Marketing Lead for SmartFace, Robert Isaac.
Nice to meet you all. Welcome.
Thanks, Robert. We're joined by Tech5 CTO, co-founder, and chairman, Rahul Parth.
Hello, everybody.
And we are also joined by ID R&D president and founder, Alexei Kitrov. Hello, Alexei.
Hello.
Well, hello to you all. Thank you very much for joining us. Robert is going to shortly tell us about an on-camera implementation of Edge AI algorithms for security or other video applications. It's based on the SmartFace embedded platform, Innovatrics flagship platform for video analytics, originally designed to run on a server, but now with the embedded version of the platform, things are changing and evolving. So looking forward to hearing a little more about that. Rahul and Alexei's companies are collaborating as partners, have collaborated as partners on a digital identity system in which people can use printed documents, even offline, to prove who they are in a wide variety of circumstances and use cases. Both projects involve biometrics running on devices at the network edge. So by edge, we mean the edge of the network. What is that? Let's start by saying it's not a server in a huge cloud farm 100 miles or kilometers, if you like, away from where you are. The network edge often means that processing that might otherwise happen somewhere else, like running biometric algorithms, for instance, happens on the device, or in these cases, or closer to where the work is being done. So that characteristic, running biometrics on a device, is one of only relatively few that our two examples today have in common. That's one of the reasons that I'm excited to have this particular set of perspectives. And one point of housekeeping that I should mention now that I think most of our attendees have joined us, and yeah, hopefully I guess we'll reiterate this in a little bit, but we would like to encourage you to say hi, and we have the chat. I believe we have the chat enabled. Do we not? I think we're running the chat. Either way, we're going to be taking questions. So use the Q&A function. That's down at the bottom of the screen. Enter your questions in there, and we'll strike up a discussion. So also joining us today is Edge IR Managing Editor, Jim Davis. Hello, Jim.
Hello, Chris.
Thanks for joining us. Jim brings deep market expertise related to Edge, and he's going to help us understand what the Edge is, what some of its advantages are. Now, Edge IR, for those who are unfamiliar, the IR stands for Industry Review. So the Edge Industry Review is the leading publication for all news, information, and insight related to edge computing. So that makes Jim the perfect person to tell us a little bit more about what precisely the edge is and how biometrics implementations can benefit from it. So with that, yeah, I'll hand it over to you, Jim, to help explain that.
Yeah, thanks very much for that. And hopefully you're now seeing my slides, Biometric at the Edge. Have a thumbs up from you, Chris?
Yes.
All right.
We can see your slides.
Thanks to Edge Computing, you can now see my slides. Again, I'm Jim Davis, co-founder and managing editor of Edge Industry Review. I'm also have a background as an industry analyst. I have my own company, Edge Research Group. And as you might have surmised, we spend a lot of time thinking about what is the edge and debating it. So Edge Computing defined what is the edge and where is it? Well, edge computing, I guess the simplest way to put it is to say it places high performance compute, storage, and network resources as close as possible to end users and devices as we can. Now, that also means that a lot of times we don't really know exactly where that is. Where should the edge be? Well, biometrics applications need to be secure, obviously, and available, but there's also performance that's constrained by things like network issues or latency issues and jitter. So one of the things that I've done, I've kept looking at this for several years now, is to look at a standardized definition to get some more precision about where the edge is. And the Linux Foundation has a group, LF Edge, that's produced a number of documents and projects, and their definition of which edges there are is a really excellent one that I follow all the time. It allows for edge services to exist at different layers that extend from the core or central cloud to the edge. So there's a few parts here that are specific to us. The constrained device edge is one of the main ones in terms of maybe the biometrics application, as well as smart device edge. The constrained device edge consists of devices such as microcontrollers that have limited memory and processing power. They are also typically programmed for a single function, such as controlling a machine. Another characteristic of these devices is that they have intermittent or no network connectivity. Now, I think in terms of the modern era of edge, the smart device edge is where a lot of the biometrics action is going to be, so to speak. Devices would include self-contained edge devices like, well, smartphones, wearables. We could also think of automobiles with in-cabin sensing. In other words, they're putting cameras in the car to monitor drivers. Other biometric uses, of course, the obvious ones would be cameras, sensors for palm detection, etc. So another place where you will start to see some mix of activity as far as biometrics applications, is the on-premise data center edge. It's described as server-based compute in secure locations. This includes gateway devices such as IoT aggregators, switching and routing devices. I think a lot of times we're going to see some straddling the divide between the edge and on-premise data center edge. The degree to which the camera itself, for instance, has processing power versus some of the functions being conducted on a server that's nearby, say in an airport, for instance. So we consider that to be another place where there's edge activity. The access edge might also eventually be a place for some of the functions to move. It's the part of the infrastructure edge that's closest to the end user and their devices. We might see more things like AWS putting servers in or near a cell tower, and developers might be starting to leverage some of that compute capacity to provide biometric services, or at least some measure of them. So I like to think of another way of characterizing the activity in the market right now, going from something that's more static to what I call Edge 2.0, or maybe we're even at Edge 3.0. I'm not sure. So the old Edge, as I suggested earlier, is fixed function. It's hard to program. It also uses older processing technology. Now, most of the reason of that is simply cost. We ride the cost curve down. Big, powerful server chips in cloud data centers are expensive. The ones that we use in smaller devices need to have cost constraints, but that also comes with, a limited ability to perform functions. So this next edition of Edge, the new Edge that we're talking about now, not that Edge that biometrics has always dealt with, is powering up, definitely. So there's a lot of changes in chip design. So we're considering things like moving from CPUs to GPUs to other types of things, chips. AI-specific chip designs in particular have been proliferating over the last 2+ years. In short, these chips are designed to process data in parallel rather than sequentially like desktop CPUs do. Now, there's a lot of different architectural approaches. GPUs are pretty common right now from companies like NVIDIA, but also FPGAs, ASICs are part of the design mix. GPUs have tended to be easier to program, but one of the issues there is that they are power hungry. So a lot of startups have come along with more novel edge AI chip designs. They've been talking about using a lot less power, and the power consumption is ranging from milliwatts actually to upwards of tens of watts. Now, just for comparison, typical CPUs in your desktop or notebook, where we're talking about the AI models being trained to recognize images, for example, those are more in the 200+ watt range. So you can see there's a huge difference in what we might be able to do at the edge with these new chip designs. Another distinction is that we're going to have better programmability. We want to make the edge more accessible to developers. And this new generation of chips and the tools, developers are going to be able to use tools and technology that they're already familiar with in the cloud, things like Kubernetes and containers. And we're also seeing a huge growth in companies that are looking to provide the tools for AI operations. In other words, providing end-to-end model development and deployment and the ability to manage things, not just when we're training it in the data center, but leveraging and managing things that get deployed more rapidly into the field. So some of the possibilities that are enabled by some of these new chips, I think we would see more things like processing multiple 4K resolution video streams, upgrading the resolution while also supporting things like natural language processing so that we're able to wake devices or do speech recognition as well as image recognition. And we're performing that on the chip itself. So Smart Assistant, translator products don't need to access cloud-based models to understand full sentence commands. Some of the other forecasted abilities, products that can respond to gesture control and perform skeleton detection, so that we are improving facial recognition by looking at deeper characteristics so that you can't do things like use a mask to trick the image recognition program. And basically, more accurate inferencing. We're going to leverage more 3D technologies, in some cases, motion estimation, things like that. Things that require a lot of processing power normally. Once we move those to the device, we're going to be able to do even more accurate detection of objects. And yeah, that would be about it from me. Looking forward to hearing everybody else chat about their view of the edge. Chris, you're muted.
Chris, muted.
Thank
There you
you
go.
for calling that out, gentlemen. I'll get this Zoom thing one day. Yeah, thanks very much, Jim, for that comprehensive overview. And please don't go too far, as we're going to talk about some applications of biometrics at the edge, and then have some discussion. So at this point, I'm going to call on Rahul and Alexi, and I just wanted to give you a quick outline of the companies that they are in charge of or leading. Tech5 is an international technology company founded by biometrics industry experts focused on developing disruptive biometric and digital ID solutions through the application of AI and machine learning technologies. A combination of sustained investment and single-minded dedication to the development of biometric modalities that capitalize on AI has resulted in Tech5's algorithms being consistently ranked in the top tier of NIST rankings for face, fingerprint, and iris recognition technologies. Tech5 target markets include the government and private sectors, and products from Tech5 power civil ID, digital ID, and authentication solutions, delivering identity assurance for various use cases. And their Tech5's partner in this project, ID R&D, should be familiar to those of you who joined us on our previous webinars, but ID R&D helps to shift the burden of user authentication from the customer to technology, and is creating a unique set of technologies to eliminate cumbersome authentication methods and deliver science-driven, highly secure, seamless customer experience. So welcome, Rahul and Alexi, and please tell us about this decentralized digital ID application.
Thank you, Chris. We're really glad to come and talk about something we think we really add value to. I will pick up on what Jim was talking about, especially on the user edge, which is the smart edge devices, and really talk about how edge computing is helping to solve one of the very hot topic, if you will, in the identity management ecosystem. As we all know, everybody is listening, talking about cyber attacks, honeypots, and centralized systems being vulnerable to scenarios where somebody's coming and stealing data. The edge-based decentralized identity verification is very important. Now, the other aspect of it, which Jim kind of highlighted, is the less reliance on infrastructure, which means network connectivity and let's say the dependency on some backends is what is driving this innovation, where we want to make sure that everybody who carries their identity can be able to prove who they are in an offline manner. Now, how do we achieve that? So what we are talking about today is a fully decentralized digital identity that one can carry in a printed or a digital form. And then the person who wants to verify if you are who you are claiming to be can simply use a mobile device like a smartphone to on the spot verify if it really is you, right? And there's a lot of value to that. This is decentralized, this is offline. If you could be in the middle of the ocean and you're still able to prove the identity of the person. And how are you able to achieve that is what I'm gonna present next. So this is a technology that we keep talking about. It's a storage capability where we are able to put not only the demographic information, but also a full picture of a person the biometrics like fingerprint templates, voice templates, face templates, everything that you would need to verify if the person carrying the ID is really who he claims to be, right? The beauty of this is that not only can you present it on a mobile phone as an identity carrier, but you can also print it on a card or a paper at home and then carry it as your credential, such that whenever you want to prove yourself, somebody with a mobile phone or a smartphone can check if it's really you. People usually confuse our technology with the QR code. Remember, QR codes are typically used as a URL. You go to a hotel and you check a restaurant, and then you click the URL. It takes you to some backend and it's checking over there. This is not what it is. What we are, developing is basically a self-contained identity container. That means you have everything you need in that one place. You don't have to connect anywhere at the backend. And as you can see, it has multiple benefits. Not only does it have a higher capacity of storing data compared to a QR code, it has multiple levels of protection, which offers the possibility of confidentiality, selective disclosure of claims, and you making sure that you control your own data. Then there is redundancy. QR codes have limited levels of redundancies. Our technology has a lot more. And then the final thing is about how many biometrics can you put in there, and the list goes on. We can today put face, fingerprint, and then we'll talk about voice, and then the compressed face image. This slide is basically talking about the other aspects of it, right? For example, why do you want some things like encryption? You want to make sure that you're in control, nobody else is looking at it. Anybody who has the right to look at your data can look at it. The error correction helps basically make the code robust, which means that any standard phone, low-end phones can actually process your data. At the same time, the ability to capture biometrics using phones, which again, you just need a phone, right? In the old days, you would need iris scanners, fingerprint scanners. Here with just the phone, you can capture face, fingerprints, and voice, and then compare it to something that's stored into the cryptograph that is issued by an agency. Basically, segueing into the concept of mobile-based edge processing for biometrics, you can clearly see from the picture, capturing a selfie is something that's a second nature to us. But you can imagine that not only can we capture the face, we can also detect liveness. And this is where we partner with ID R&D to ensure that the person who's capturing their face is the real person. At the same time, we are able to create a biometric template that can be then used for matching that with the pre-enrolled and stored face picture into the cryptograph in an offline manner. On the right, you can see that we are now able to capture fingerprints using mobile phones, and you can match these fingerprints with a standard fingerprint sensor captured images. So this basically means that now with the phone, you're able to capture multiple modalities, use that not only for security, but privacy aspects of the credential as well. We as Tech5, we are, as you can see, we are a biometrics company. We all build algorithms, but then we are also in the credentialing business. We are building this innovative ways of decentralized identity management and credentialings and digital IDs that can be used in online, offline mode. We constantly participate in industry evaluations like FRVT for fingerprints. There is another evaluation track in IRS. From here, I would segue into the discussion where we are really leveraging the benefits of voice. And I would like Alexi, our partner, to take from here and explain and talk about the voice technology.
Absolutely, Rahul. Thank you so much. So let's move into the next slide and talk a little bit about voice. But first, ID R&D is a developer of the core biometric capabilities. So we're developing the core biometric components that then our partners integrate into their successful products and platforms. And today I want to give a quick overview of the two domains and two key contributions that ID&D is making to this very exciting new product that Rahul is talking about. So let's talk about voice first. We're extremely excited about voice. We've been working in the voice domain for quite some time now, but we're seeing that voice is gaining a very strong traction, strong popularity right now for two key reasons. One is the voice is the role of voice is changing. It used to be a modality that lived in a call center, or I would say would die in a call center, but now it's expanding into the wild because voice is becoming a new interface. When we're thinking about the way that we're communicating with the technology world, the role of voice as the means of communication with technology, with products, with capabilities is constantly increasing. Think of Alexa. What's the interface of the Alexa? There's no screen. We can't really touch anything, right? So it's all done with voice. And if companies are looking to provide secure access to financial transactions or sensitive information through that channel, voice biometrics is the right way to do it. Voice biometrics is also I would argue an ideal second modality in the multimodal biometric implementation. A few reasons for it, specifically on the edge. Voice biometric has this natural user interface or user experience. We just need to say a quick phrase, which is now very natural to us. We've also seen a very significant breakthrough, a very significant leap in performance of the voice biometric algorithms. Just a couple of years ago, we were talking about the single percentage points when it comes to the false accept scores. Now we're talking about the hundreds of a hundredth of the percent when we're talking about the false accept. So a very monumental shift in the type of quality and the type of security that that voice can provide. But when we talk about the improvements in performance, it also covers such important things as latency, which means that it's working extremely quickly, and also the size of the size of the application and the size of a template, right? So the size of the template for the voice biometric right now can be counted in bytes, in hundreds of bytes, not kilobytes, bytes. That's how small it is. So you can really pack a lot of information, and you can really deliver the convenience of voice biometrics, especially in the multimodal environment, with the new generation of technology. And when we're talking about this new generation, there are a couple of very handy benchmarks that the folks can use when they're looking for partners in voice. ID&D have been actively participating in all the leading benchmarks here. Two that were conducted in 2022 that I want to highlight. One is called Spoof Aware Speaker Verification Challenge, which is a very interesting one because it combines the speaker verification, which is matching, which is core biometric, and liveness, right? So now we're talking about liveness, the second domain that I'll quickly touch upon. And then the second one is Vox Lab 2022. That's another test that was done on the real life audios in real time, in a real type of environment. So voice is proving it's extremely high performance, not only in the lab, but also in the wild, in the real-time type of situation. So I would direct the folks to take a look at the results of the challenges, see what the new generation of the voice biometrics can deliver to your solutions in the new changing world where voice is becoming an increasingly important piece of the communication that we as humans have with technologies. I mentioned liveness, and this is the second domain that I want to touch upon today. So Rahul, if we can go to the next slide. Liveness is a very important concept. When we're thinking of the biometrics, a good biometric system must be answering two questions. Is this the right person? And that's what biometric matching is doing. And then secondly, is this a person, right? Is this a person or is this a picture of a person? Or is that, something like this, somebody can try to spoof the system and get the access to some type of resources with more elaborate spoofing attempts like this. So we're trying to distinguish not whether this is a specific person, but whether there is a person in front of the device at the point of the biometric transactions. And at ID R&D, we're developing liveness solutions in 3 key domains. So we talked about voice. Specifically in voice, there are 2 key attack vectors. One is synthetic voice, that is creation of the new voice out of the existing recordings. You all heard, about the good use of this technology, where I don't know if anybody saw the Anthony Bourdain documentary, which was narrated by his voice. And then the second type of attacks is recorded voice. So we're distinguishing between me speaking right now and somebody using a recording sample of my voice. We're also providing a solution for document liveness, right? So we're trying to establish whether during a transaction, whether we see a document or a picture of a document. And then finally, the facial liveness. So that's where that's where my good friend comes into play, the mask. Because here we provide the answer to the question whether there's a person or where there's a presentation attack. And the key thing that combines all these 3 domains is the frictionless approach that we bring to the table. The idea of the biometrics, the only way that the biometrics are successful is when we're solving problem where we're simplifying the user experience. And that's where the frictionless aspect of it comes into play. It's more difficult to do, but that's the only way that we can gain traction and gain trust of the users. Rahul?
Thank you. What I'll do is I'll go to the next slide. And again, just adding on to what Alex has been saying, the whole idea of a useful ID solution or identity solution is when it is covering the digital divide. And when I say that is basically if somebody is able to prove who they are without having access to a smartphone, to digital infrastructures, internet, all of the digital skills is where we think that, is going to be really useful. And because of the high penetration of mobile phones, this we think is the real answer to the whole problem of digital divide. So all said, I would say that, all the things that we just talked about is, fingerprints and face and voice and liveness, they actually go into this, our Tech5 digital ID solution, which is offline. And we have identified more than 40 use cases, and they're growing, where this technology will basically help taking that identity verification to the edge, which basically means you can really reach to the masses that were not reachable, depending on some of these previously deployed technologies. So with that, I would, call it a wrap, and over to you, Chris.
Thank you very much, Rahul, and thank you, Alexi. Very interesting stuff. And I just want to call out something there that I think was very well explained, but I think is pretty novel, right? And very well, one of the novel elements, or a couple of the novel elements, let's say, here, because there's a lot going on, right? And one thing that's really striking to me, just watching the development of these kind of technologies, is that we've got biometric data being stored not even on the device, as in on the on a smartphone or some other electronic device, but this is beyond the network edge. This is like the edge of like a social network, essentially, right, or a sociological or government kind of network, depending on who your issuer is. So that's really interesting. And then the actual computing part of it, the algorithms, the AI, this is running on a device that is not networked necessarily at all. So there's kind of a bonus edge in the application, right? Is that fair to say?
It is. I mean, it removes the necessity of mobile devices by the ID carrier. As you said, you can see it's printed and can be printed at home. It removes the demand for smart cards and chips and plastic, which is detrimental to the planet, and actually makes sure that you can easily issue this credential that somebody can carry. And then the people who are authorized to verify, which could be government officials, are just carrying a smart device to do that. So yeah, essentially the power of computing at the edge. What it's doing is a social benefit of making sure there is inclusion, everybody in the society can participate. Second is you do not need to be digitally skilled, no access to infrastructure, and the vital, most important thing, security and privacy, and removing the liability from the governments to not have centralized data centers. And we hear these hacks every day. So, and because they're so cross-platform compatible, like what Alexi was saying, so you can capture a face on a mobile phone and match it on the laptop's webcam, or you record on the laptop and then verify using the mobile phone in the field, right? So we do believe that this is going to really change the definition of decentralized identity, on the edge.
And yeah, utilizing the edge in a kind of an innovative way to deliver some of these benefits, like even that Jim was referring to at the beginning, but and taking them to a new place. So that's very exciting, and I think we're going to be hearing a lot about that in the digital identity space over the months and years ahead. So thank you again very much for that, and please do stick around, gentlemen. I think we're going to continue our discussion as we go. But right now, I would like to welcome Robert Isaac, and I would just like to give you a quick few seconds on Innovatrics, which is an independent EU-based provider of multimodal biometric solutions. The company's algorithms consistently rank among the fastest and most accurate in fingerprint and in facial recognition. Innovatrics has been for 16 years partnering with all types of organizations to build trust and flexible biometric identification solutions. Innovatrics products are used in more than 80 countries around the world, and to the benefit of more than 1 billion people worldwide. So thank you very much for joining us, Robert. And you're going to tell us, I understand, about a fairly different kind of application of edge biometrics. So yeah, please do take it away.
Thank you very much for the introduction and welcome. Yes, over next maybe 5 to 7 minutes, I will walk you through the biometrics deployment at the edge, but meaning I will focus more on security use cases, which is where we focus heavily with the edge computing and processing our biometrics. Before I start, let me just highlight that currently there is more than 1 billion cameras deployed globally on a very simple mission, which is not always successful, and that is to improve the security. In the past, majority of the CCTVs have to be monitored and guarded by people in order to provide a meaningful value. And that means not just the people, by army of people. And also what we have learned over last years is there is a very little correlation between the number of the cameras deployed and the security rate itself. Main reason is usually very simple, and that's that there is a huge amount of data or unused data that are being produced and generated by these CCTVs. And we may say that these cameras are not smart at all. They are simply dumb. And therefore, back in 2018, we have introduced a smart face video analytics platform, which was back then pretty much our proprietary face recognition algorithm embedded within a robust API. And our partners, system integrators, security vendors have been using this platform to deliver projects involving and also including border control, stadiums security, gyms, offices, hospitals, many others. And we have learned a lot over these challenging years. Not only that every project is very special, but especially when deploying the large-scale project, and that means not several cameras, but hundreds or thousands of cameras, is very unique. Our partners found out very early that infrastructure itself has some limits. The same, their budget for processing the video streams traditionally, centrally on a server side. And therefore, this year, and I am very happy I was part of this journey over the last 6 years, we have introduced the SmartFace version 5, which together with the SmartFace embedded, which is the version that runs directly on the edge, on the side, on device. Thanks to this approach, we can make every camera smart. And now let's talk about a little bit more about the challenges which are involved within deployment of proactive or preemptive public security, which means you want to minimize the security incident before it happens by analyzing the situation and providing the right type of notification. We learned that, of course, for security matters, you need to deploy large watch lists. Consider multiple watch lists that include millions of faces, and you need to receive a notification within milliseconds regarding the user's identity. That's very important, but what is one of the most important is especially related to architecture. And we need to handle the fact that, as I mentioned earlier, simply it's not possible to deploy a network cable everywhere. It's not possible to have a reliable power source everywhere. And therefore, you need to have a very flexible, scalable architecture, because one day you may need to deploy your technology directly on the edge. Another day, the situation requires to process everything, all the camera streams centrally. But usually what we see, it's a combination of those approaches. And for such, let me maybe explain on a very simple example from the security project. This is the smart airport, or it can be a station, where in order to provide a security, high level of security, you need to deploy a large number of cameras. Consider hundreds of cameras. For full HD, which is this, I would say, very low basic, in general, I need to process at least full HD resolution. You are sending from camera to the server over the local or public network approximately 4 megabits of data per second, which is perfectly okay if you have one camera or two cameras. But if you have hundreds of them, then you will see that the throughput of your network has some limits. And the same, the limits have your server infrastructure. Therefore, we introduced and we came up with the idea, what about to offload the heavy job that happens directly on the server? And that means especially face detection, then a landmark extraction, face template extraction, and also depends on the use case, full matching directly on the edge side or on the camera side. And with this approach, suddenly you are not sending megabits of data, but kilobits of data, which makes a significant difference to your network. Plus, especially if you need to deploy a large scale of or a large number of devices, the economy of scale works perfectly here. You will see how much cost you will save, especially from the maintenance point of view. And thanks to this approach, by deploying or doing the heavy processing of the biometrics directly on the edge, the server side can be then minimized, or you can create a very unique infrastructures, which we call from edge to cloud infrastructure. And you can combine various devices, various approaches according to the situation needed. That means you can use smart cameras and do the full identification, meaning also matching directly on the camera side, or you can pre-process the cameras and do maybe just the matching centrally, or you can send full real-time streaming protocol, RTSP stream to the server, or you may use also various smart devices, like, for example, those smart glasses, where we are running the facial biometrics directly on device, and we display users the information about the identity of the person staying in front of the device. And as I mentioned, especially the maintenance and the deployment options, this is very important, just very high comparison. If I want to process 100 cameras, which is, I would say, Nothing special in security deployments. If you need to monitor, let's say, building like an airport, to process 100 cameras, typical resolution full HD at 25 frames per second rate, which is a standard for the security purposes. With our technology, which is pretty lightweight, you need to consider to have dedicated one server core and approximately 3 gigabytes of RAM, which makes very high level calculation. You need approximately 3 enterprise servers, which cost $15,000 approximately. Of course, the range can be from 10 to 20K, depends on the hard disk, it depends on the storage, depends on many other details. Plus, you still need to buy a serious good quality CCTV cameras or IP cameras, which in average might cost from $300 to $500, of course, depends on your distributor. By deployment through the edge, you can either deploy edge camera, which do heavy job directly on the camera side, or you can deploy industrial PC or smart AI box, that's how we call it, or our partners call it. And then pretty much you don't need any powerful server, you just need a very simple maybe laptop or service in the cloud that just works and refresh the watch list directly on the devices. Or you may send just a tiny crops, facial crops that has 1 or 2 kilobytes for matching to the server side. And also a little benchmark to give you an idea about the performance directly on the edge. This is on the camera processing. That means we have ported our face recognition, smart face embedded to Umbrella family chips, and we can achieve face detection of face within 11 milliseconds, template extraction within 30 milliseconds. So below 50 milliseconds, you have also information about the user's identity. This is what we call on-camera processing, because these Umbrella chips are usually used in the cameras. But we also support various other platforms like Halo, NVIDIA Jetson, a very well-known one, which is like an industry benchmark. And still we can achieve tremendous times considering the size of those neural processing units, of those NPUs, of those tiny chips. So simply, there are 2 approaches we generally support, either smart camera or edge device or industrial PC or AI box. That's how our partners call it. And you can also consider that one AI box can support more than one camera, of course. So we consider from 2 to 4 channels for cameras. It all depends, of course, on the resolution and the frame rate that requires your use case. To open the door or the turnstile, you need to, for example, process much lower resolution than, for example, typical security surveillance use case where you need to see as much details as possible, of course. And also, just to give you an idea about what does it mean the edge from our point of view, it would be very difficult for me to deploy the regular edge device. Therefore, I have help with this old phone. And I like to showcase what we are actually doing directly on the edge and what we are doing on the server, because this can be one of the deployment. So this is my phone. My phone is currently streaming processing the stream. We have SDK running directly on this phone. We detect the face and we send a tiny crop to the matcher, which can be in the local cloud, in the public cloud, wherever. And with this, you are offloading your network, because otherwise I will have to simply upload my video stream to the server somewhere, which would be very heavy for my data plan. So especially if you have situations like officers in the field, they can identify user very quickly, show me your ID, you don't care what's written on the ID. ID can be even very old. You can compare with the user and see the information immediately. So this is what does it mean from our point of view, the edge computing, and that means we can support pretty much any device in any situation. That's all from my end. Thank you for your attention, and I would be happy to answer your questions.
Yeah, thank you very much, Robert. Very interesting presentation, and yeah, and I want to thank you for going through that sort of back of the napkin cost estimate. Very interesting stuff. The speed, you can really see where the benefit comes in for the edge, for deploying the technology at the edge and running algorithms on the devices. I actually want to throw you a curveball right now, Robert, and depart from a previous discussion we had about what I might ask at this point. And you referred to the to privacy implications a little bit here, and for things like security use cases, access control. Of course, you're in Slovakia. You've got GDPR considerations for yourself and a lot of your customers, right? So, yeah. So my understanding then is that you could take a watch list, be it a white list, black list, whatever it is. You put it. You could enroll people to the device, have your database, and then because the matching's happening and everything, that's going to make it easier to, one, protect people's privacy, and two, to comply with rules like GDPR. Is that fair to say?
Partially, yes. Partially, yes. Of course, it will help you, especially to manage the data for edge cases. Yes, exactly. The data, personal data, stays on device, but still, from GDPR point of view, you need to have a consent, regardless of where the data are being processed, either centrally on the edge. But we see especially these edge components or edge approach, especially very useful in the industries where you simply replace unit by unit, because from security point of view, if you breach the central database, then you may have millions of identities, in stake. Instead, you can have a local, cameras, local watch list with thousands of identities. So it makes sense. Not only from the, of course, cost perspective, but definitely from the security and the risk mitigation. You don't want to risk your whole infrastructure central when you can still have partial units, do the processing there. You may have one central unit, with different encryption, do the post-processing and so on.
Thank you. Yes, that makes perfect sense. So there's a lot of different areas of benefit really to deploying technology at the edge. One thing that I want to mention at this point, we've had a few questions in the Q&A and a couple of answers. I just want to mention for those interested in seeing some of the slides, please email us following the presentation. You can contact us at webinars@biometricupdate.com. I noticed Rahul has put in info@tech5-sa.com. I'd like to invite the rest of you, Robert, Alexei, Jim, feel free to reach out and to respond in the Q&A function. I also want to encourage all of you who are with us today to ask any questions you have at this point, and we can have a brief discussion before we run out of time. Before we get right into that, or before I turn things over to attendees, I would just like to ask Jim, can you give us a sort of a bird's eye view or a rough estimate of how mature this technology is at this point, the edge ecosystem, let's say, and how quickly the market is growing?
Yeah, I don't remember all of the market research figures. I know we've cited Deloitte figures about edge AI chips, for instance, and it is expected to grow rapidly into the multiple billions of dollars. In terms of maturity, it's pretty interesting to see some of the companies that I've written about as startups. Innovatrics is already using their technology. Halo is one of them. Blaze is another. And those are, in the past, a new chip design was something that took, a long time to get to market because, it's a physical product, right? And that design process is complicated. But programming it and getting it into products after that, it was also a long time. So seeing those in the market being used in that fashion already suggests that, our thesis about programmability, for instance, is helping these technologies come to market fast and be used. So it's still early, but it's maturing. There are a lot of other areas where there's plenty of rapid advances, especially in terms of algorithms. A lot of companies are developing technologies there, and those advances keep coming. I think in terms of maturity, we're starting to see a little bit of mergers and acquisitions, which is another another sign that there's this balance between emerging and maturing. The bigger mature companies are going to start acquiring these technologies. I don't know if it's really relevant to this company, this biometrics market at the moment, but just the other day, there was an acquisition. Is it Synaptics, I believe, was acquiring a company based in Israel for some of their edge AI technology that's going to be incorporated into a platform that combines wireless plus visual sensing. So yeah, things are still fairly early, but not immature.
Not immature and maturing quickly. It sounds like more quickly than we would expect, or than we might expect. Great. Now, another question that occurs to me is that I want to throw over to Alexei is you were talking about matching and also about liveness detection, and so I would like to ask if you can put into perspective for us what are the relative size and processing needs for those kinds of algorithms. I think for those of us involved in biometrics, you're often going to want both, but they're not. Are they the same, or is there a big difference?
Yeah, so these are two different technologies. So you can and you should combine them together because liveness provides this very important assurance that that you're not running the biometric analysis on the picture, on the video, or on guys like this. Let me bring my good friend again. So by the popular demand, and the same goes to voice. Because what liveness and voice can do is to distinguish between a human voice and a recording of human voice, or human voice and a computer-generated voice. And a lot of this analysis, what's very interesting is that the technology right now is much more advanced than the abilities of a human being. So we cannot distinguish between a human voice and a recording of human voice by just listening to it, right? Or we cannot distinguish between a picture of a person and a good picture of a picture or of a person. So this is truly a necessary part of the biometric check. So as far as the size and the and the performance, we are seeing some very significant improvements in this, and we're seeing a very strong performance, and as a result of it, the market is accepting liveness and demanding liveness and being part of the transaction. So if we're looking at the facial liveness, if we look at some of the leaders in the space, we're collectively reporting, I think, about a few billions of transactions a year. Right, so this is the scale of the of the liveness, or the facial liveness check that are happening right now. Voice is gaining traction as well, and part of the reason why voice is gaining traction is that voice is probably one of the most accessible modalities, because microphones are everywhere. Right, there's a microphone in every phone. There's a microphone in every now car. There's a microphone in every smart home, and so on and so on. So again, going back to the point that I made, that voice is one of the most ideal second modalities for the multimodal checks, because you can do it. You can do that check simultaneously with the with the facial recognition, because you can talk and take picture at the same time, and you can get essentially 4 layers of biometrics by clicking just once. And this is a very and this is the highest level of performance that you can provide to the customer at the very user-friendly user experience. So and the computational cost, you know, the memory cost that we're demanding right now extremely low. So the combination of voice biometrics and voice liveness, we're looking at we're still in the single-digit megabytes. So it's not we're not requiring a lot of space on the mobile device or on the edge device, while the voice can bring a lot of value to the process.
And to put that in the context of the application, the footprint does not, therefore, it sounds like you're saying the footprint of even combining these multiple modalities, covering the liveness for both modalities, is still not going to require the person using the end device to have necessarily the very latest and greatest, most powerful smartphone on the market, right?
No. Yeah, so you can use the you know, with the footprint requirements like this. Yeah, you can use kind of all generations of phones as well. Absolutely.
Great. Well, we are actually slightly over our hour, so I think we better wrap it up at that. But I want to thank all of you very much for sharing your insights today. Thanks. It's been just very interesting to me, and I can see to participants as well. And I want to thank all participants for joining us and for your attention today. And again, I want to just reiterate, you can email us, webinars@biometricupdate.com. We'll have some slides available. We are also planning to put a recording of this event up on the web so that you can go back and take further notes and clarify any points you want. So thanks again to everyone for joining us. This is Chris Burr from Biometric Update. Thank you very much. Tech5, Innovatrics, ID R&D, and Edge IR. You should know these names if you're interested in biometrics at the edge. And if you came with questions about about what exactly that is, I hope we've answered them. If not, please do reach out. And thanks to everyone. Have a great day.
Thank you very much.
Thanks for having us, Chris. Bye-bye.
Bye-bye.
Take care, everyone. Bye.